Hello, welcome back. This video we're going to work on some of these light assemblies. Just to use if we have power on certain tracks or whatnot. I have this style. I only have one of them, so I can only identify one piece of track that's got power on it. So we're going to go ahead and create something that kind of looks like this with some resistors and some little LED. Now this one's really ugly. I'm going to try to do something nicer for the next video. But that's an example of what we're going to do, and it's that simple. It's some resistors and an LED. Now, I went ahead and I used this style clip instead of the this style. And it's basically because this clip will clip into the 027 track, but it will not clip into, I don't know if you can see that very well, the O gauge track. No matter what you do, it's not going to clip in. So, but I want to be able to use that track signal if I go ahead and run the 027 gauge train on the O gauge track. So I want it universal. And since they're the same distance between each other, these connectors will fit on the O gauge track. They line up just the same. So they'll pop in. I can use them in either way. So that's what I'm going to do. Now I went ahead and I cut some of these wires and put them through the little holes in there. I don't know if you can hardly see that. But what I'm going to do is use those as solder too. If I don't want this to be used anymore, I can just simply remove the copper things without destroying the track clip. I have some of these that I've soldered the wires right to the clip because the clip was broke, so I wasn't wasting it. But that's what I'm going to do. Now, to find the proper size resistors you want, I was originally going to use a potentiometer, put the wires between LED, one side of the power supply and the other side of the power supplier on the potentiometer, starting at the highest resistance level using the meter, and then slowly backing it down till we see the amount of brightness of the light we want to get. I'm then measuring the resistance across there and then figuring out what resistors we want. And I'm thinking about 450 ohms of resistance. This red one's about 500. It's got three 1500 watt resistors in it, or 1500 ohm resistors in it. And it's a little dark, so I'm going to go a little bit less resistance. Now, instead of doing like this, now we could get a 450, 400 range resistor. I used the 1500s because that's what I had at the time, and it worked. But instead of making a mess like this, I want to go ahead and make something that kind of looks like this with 3 resistors. I just think it kind of looks cool. And each resistor is good for, I don't know what these are rated for wattage, but the wattage can be dissipated over 3 resistors. So keep it a little bit cooler. And like I said, I think it looks cooler. So what I'm going to do that, I went ahead and I bent some of the resistors like that into that shape. And I simply used just a pair of needle nose pliers, and I bent the resistor lead over a little bit, and using the pliers I just bent it back kind of in a straight. Did the same thing on the bottom. Kind of like that. Bent it back straight to get that kind of a square angle. There, bend it. These are pretty easy to bend, so, but I just use the pliers as a spacer. Now we're going to do that. We're going to put the LED in. We're going to put each of the resistors in parallel to each other. So we mean have one tied together in 3 places, like this one. So each one's going to share a load in parallel with each other. If we were in series with each other, each one would drop the ohms would add up to each other. This way we're going to go across. So we got a 1500K resistor, another 1500K resistor, and we'll put a 1000 ohm resistor in here to bring it down to about 450, just to get a little bit more power out of that light. And we can see the difference once I hook it up. So I'm going to go ahead and solder these together and see what it comes out as. Okay, I got this soldered back together. I mean, it looks pretty rough, but it's there. And I don't know if you can see, I kind of went to put the resistors in a triangular pattern around the LED. Then I took a little bit of this black heat shrink tubing, and I stuck that between the pins so make sure nothing grounds out if this ever gets bent, if something hits it. I went ahead and jumped the track to our transformer. I have this other style light on there as well, so we can see all this light up now. I went ahead and turned the power back on. You can see the lights lighting up, and we can go up and down with our power. They come on and off. Now, I'm not super thrilled about the brightness. I think I could use a little less resistance across there to make them a little bit brighter. Again, this red one's three 1500 ohm resistors tied together in parallel, so it's about 500 ohms. This one is two 1500 ohm resistors and a 1000 ohm resistor, and you can definitely it should be a little bit brighter. Now that could be depending on the color of the LED too as well. So I think I'm going to clean this one up, make it look a little bit nicer. Also, I want to mention that LEDs are polar, meaning that they have a positive and negative to them. So if you're doing this in a DC circuit, the polarity of the track will make a difference. Being that we're working with an AC system, it doesn't make a difference how you wire the pins on there. So I might make another one of these, just so we have it. Let's see. I definitely added some expansion to my track. I don't know how well you can see. Bridges and a couple more trains on there. We're going to talk about that next time. And that's why I wanted the LED lights, so we can tell which tracks are on and which tracks are off. Because that's what we're going to get into, turning them on and off and doing different circuits with them. So, okay, thank you. Leave a comment, leave a like.